Hi, everyone. On today's episode of Engineers for Communities, we're going to be talking about I&I, Kwin Peterson and RH Borden. He's got a really simple device that can be installed in manholes that can help you locate it within a few hundred feet. Let's see what he has to say. And I've got Kwin here with RH Borden. Thanks for coming on the show today.
Hey, it's my pleasure. Thanks for inviting me.
So we're at the conference, a lot of rural water municipalities, they're dealing with lots of different challenges. Kind of what do you see as a big challenge?
Well, the big challenge that every municipality here at this conference is facing, there's a shortage of guys. I don't know of a single entity that is here at Rural Water who has fully staffed. And that's one of the things that is really our driving need here is for our company, it's how can we use technology to overcome resource shortages, whether it's guys or budgets or the fact that the pipes are really old and we don't have enough money to fix them. And it's costing more and more in time and money every year to take care of these ailing pipes. Even if I can get a grant for it, I don't have the guys to execute what I want to do.
Yeah.
And in some cases, I don't know what I want to do. I'm working with my engineering firm and they've got some ideas, but it's not at all clear. And I'm also having a hard time prioritizing, like, am I going after my flow problems? Am I going after my infiltration problems?
Yeah.
Am I going after the problem that I have with my blower that keeps going down? Or I've got 3 lift stations that I'm out there every week doing some dumb thing with this lift station.
Right.
And I know I can get it fixed. I don't know how to get it fixed. Engineers have to remember, as much as you would like them to be proactive, and deep down, I've never talked to an engineer who says, yeah, I love going out on a call on Saturday morning at 2 a.m. I have never met anybody who lives for weekend call outs.
That's so funny.
And so once you paint a picture for them of, if you're an engineer and you can present a solution to one of your clients that is going to head off an issue, if you can explain it in simple terms of, okay, this problem is going to save you X and X and X and X, and it's going to prevent you from having to go out on calls on the weekend. I've been in a city, there's one city out on the West Slope, and they had kind of thrown their hands up. There's like, no, there's nothing we can do. We just have to deal with being reactive. And I was able to give them some data and do the math with them saying, okay, this means that you actually have to do this much work. Can you do this much work? And they're like, yeah, we can. And the lights went on in their eyes. And it was like, oh my gosh, we can actually get ahead of our problems. And we had no idea that we had the ability to get ahead of our problems because nobody had broken it down
to a small enough
numbers
and more manageable.
Yes, they said there's no way we can get all of our pipes clean. And I'm saying, the data says you have to spend 26 days doing this. And they're like, I can do 26 days. You give them a number and it's like, damn, we're doing it.
Yeah, I just recently talked to the people with the lead, copper, and compliance. They're working on that. And what happens is EPA publishes this huge thing.
Yes.
And they're like, that's like 180 pages.
Yeah.
My eyes glaze over. But then when you give them one number, it's 26 days.
Yeah.
Oh.
Yeah. So if there's anything I would encourage the engineers watching this to do, it's think about what your solution means in terms of the life of your client, the day-to-day life of your client. Break it down, you don't have to dumb it down, but you do need to break it down and make it digestible. Give them, Napoleon said, a leader is a dealer in hope. And if you can give them hope, backed up by, here's an easy number that you can hope on, it just changes their world.
That's awesome. So recently, and this is where I find kind of what you're doing is really interesting. I had a client, they get 100,000 gallons all through the winter at their plant average day. And then all of a sudden in June, huge spike, 350,000 gallons, crazy.
Yeah.
And it's really funny because every year in June, I get the same call of like, this is crazy. Like, we need to fix this. And then we don't do anything. But you're doing something about this.
Yeah, so we've had people talking to us for years about, is there a solution that you have for I&I? And we haven't had anything up until about 4.5, 5 months ago, just before WEFTech. we were able to find this tool that is we feel really confident about and comfortable with. We're deploying it across systems in many states now. And last year was the year, right? We saw here in Colorado plant volumes go 5x, 6x. There's a plant here on the North Front Range that went, they're a 1 MGD plant. They went to 15 during a storm.
What is that?
Just barely holding on to not discharge partially treated wastewater, and they barely made it. But it was a big eye opener for them. It's like, we got to get on this. But what does getting on this look like? So what they did, they've done some smoke testing since then on places that they think maybe this is going to be. So last year revealed a huge problem with I&I, and a lot of places who didn't realize they had I&I or didn't have a big problem with I&I suddenly found that they have significant potential problems with I&I. I go and I talk to districts and to small cities, and I'll say, do you have an I&I problem or do you have an I&I problem? And right? Because if you're getting these giant spikes down to your plant, there's a danger of overflowing your plant and getting a letter or a cease and desist or something from EPA or CDPHE. But what people who think they have a problem, it's not that bad. Again, if you start doing the numbers, okay, you think you have maybe 80,000 gallons a week of groundwater coming in. How much is it costing you per gallon to treat that? And is it $4 a gallon? Is it $3 a gallon? You do the math, and immediately that kind of problem becomes a problem.
Yeah.
If you get a letter from CDPHE saying, hey, by the way, what's your plan for expanding? Because we saw that you went over your 80% of your discharge limit. Then you're looking at a $40 million problem. And I&I suddenly becomes the top of your list. So what we're really excited about is we were looking at all these ways that you can treat or locate your I&I, right? And things like smoke testing or putting a camera in the pipes, doing flow studies where you install a couple of flow monitors in your system. These are piecemeal, they're kind of task things. And what was missing is, what is the programmatic approach to locating my I&I? And what we were able to find, and it's only been in the last couple of years, is sensor technology has come a long way.
Yeah.
This is a device, it's the latest generation of ultrasonic sensors. They're inexpensive, they're mass produced. We got a whole warehouse full of them. And what that means is we can deploy them as a network. We can deploy them en masse. We can connect them all up on the back end with tying them into weather, highly localized weather. We can tie them into each other, so we can do the subtraction problem that comes with I&I all in the back end. And we've got all this data visualization that we can do, so that the upshot is we can, over the course of maybe 1 or 2 years, depending on where a system already is on their understanding of their I&I, we can really home in on 80% of your I&I is happening between this manhole and this manhole.
Yeah.
We don't have to go after all 400,000 feet of our system. We don't have to smoke test 400,000 feet, right? We don't have to try and crawl through a camera during I&I season
and watch it.
And watch it, because we can let the sensors do the watching for us. And then once we've nailed down, and it really is this 80% rule, it's 80-20. The majority of your I&I is coming from 2 or 3 places. And with the sensor network, we can say, you need to focus right here. These 8 houses, something is happening in these 8 houses. Maybe they've connected their downspouts. Maybe they have some other illicit discharge. Or maybe there's a giant cottonwood tree next to the ditch that has broken the pipe and it's running. Yeah. And once you're no longer looking for the needle in the haystack on your I&I, it becomes really easy to solve it. Yeah. This is not a flow monitor. What this is a level monitor. We can turn it into a flow monitor if we need to, but that requires confined space entry. What we're really looking for here is, what is the right tool to do the job? And what we've settled on is these level monitors, along with good analytics and proper setup and proper back end, we can do the work of finding out where the INI is. That's what we're looking for, is where exactly do I need to look for my INI? So these basically hang from a tension bar inside the manhole on a chain. They're connected by Bluetooth and connected by cellular. We try and connect them all cellular. There's not a cellular signal everywhere.
Especially rural Colorado.
Yeah, right. So we did a system-wide assessment yesterday in Milliken. It's the first step of their assessment. We used 4 of these, but they're all tied in. We were able to get cell signals on 3 of them. Those 3 cell signals are going to tell us what's happening. Is there an event happening right now? And then afterwards, we can drive by and pick up the data from the the sensor that we're only able to access it by Bluetooth. And we can feed that all in and then visualize, okay, here's our next step. So in the case of Milliken or any other city where we don't know which basin is contributing it, we're going to put a wide sensor network strategically placed at outfalls of basins. And that way we can look at which basin is our 80% problem. And then the next year we can go in and just blanket a basin with sensors and say, where in this most contributory basin is the problem happening?
So you mentioned it's a level sensor, and you'll set up a couple of them. How does it kind of on the back end figure out the difference, with those levels? How does it, because it's monitoring the levels in all the manholes within a basin.
Right.
So is it just referencing the difference in the height of the waters? What's the magic?
So that's at its core, that's what it's doing. Each sensor is saying every 5 minutes, how deep is the water? How deep is the water? What the back end does is it takes all of that together, and we'll see the diurnal flow, because we're looking at it every 5 minutes. We'll see the diurnal flow, and then we'll see a spike on a sensor. And we can tie that into how much rain is falling right now, or how much water is in the canal that is next to it. We can do that as well. Drop one of these on top of a canal. And then we can tie those 2 things together. The magic happens when we have the computer take all of that data, cancel out the noise. If this sensor is not seeing a spike in flow, and the sensor downstream is seeing a spike in flow, then we're going to note that and quantify that. The computer is going to flag that and do that analytics. But we have to understand that downstream of this one, there is more. There may be a whole other basin that first basin drops into. So we need to cancel out the spike in flow that's happening here for the downstream sensors.
So it doesn't think it's like
an exact reading on every sensor, so that we can really zone in and say, this is where your biggest problem is, and this is how much it's costing you. Because again, we know how much a gallon of water it costs to treat. And if we can say, this is contributing in that last storm, this manhole problem here contributed 100 gallons per minute for 3 hours.
Yep.
And you can say, well, 100 times 4, that's how much am I treating now? Or if you know that you're getting close to that 80%, and all you want to do, or all your board wants to do, is get underneath 80%, well, we can say, okay, this spot, if you can address this spot, you'll drop down to 72%.
And then we can figure out, then maybe a method like TVing, going in and like saying, okay, what kind of repair is applicable here? Because if you just say the issue's here, well, how are we going to fix it?
Right.
Because it could be a root intrusion. They might need a point repair. So that, is that where you would see those technologies coming in?
Yes. So the tasks, the tools that we talked about earlier, the smoke testing, the cameras, even a level monitor, there a flow meter, there might be a call for that, but targeted it. Let's not just try and find the needle in the haystack. Once we've found where in the haystack the needle is, then we can start using these other tools. If we're just going out on a 400,000 linear foot system to find our INI, somebody yesterday told me we may as well be using a divining rod, because we're just
witching stick. Like how the pipes are located.
Yes, because we're just shooting in the dark, and it gives us a feeling of we're doing something, but we're not doing the right thing.
So you have pretty visual software that can we go take a look at that?
Yeah, absolutely.
All right,
let's head over.
You've got a little presentation here to kind of go over what the back end looks like. What's the visualization of the data that you're collecting in these manholes?
So what we've found is very few people are good at data. Engineers are fabulous with data. district managers, city councils, district board members, not great. So one of the things that we focus on is visualizations. So we got a couple of things that the engineers can use as we talk about these, presenting this data. This is just a screen capture of a visualization tool that we use to talk about target basins and major basins in the early steps of planning a project. It's a very visual tool, and it's pretty slick. It calculates footages upstream and downstream. This is what the actual data looks like in the portal as we're gathering information from rain events. And it ties into that. This is what the back end data that's driving it. So we can see we've got this manhole here, and we can see the regular diurnal flows that are happening. And the interface is going to flag this manhole as having a weather-related incident.
Okay.
And we can see that because we're seeing spikes that are tied in with a weather event. And then we also know that it's not visible, but downstream, all of the sensors that are downstream are having these spikes cut out,
Yeah.
so they don't slow down.
So just real quick, so like you said, this is where you're just blanketing that network.
Uh-huh.
And then in here, we've got, nothing's getting flagged. So it's most of those charts are looking like this red one here.
Yeah.
And then boom, and then downstream, this has already been taken out.
Right.
Okay.
So we can, every sensor is standing on its own.
Yeah.
But the reason it can stand on its own is because they're all connected.
Gotcha. Okay. Understood.
These are other visualization tools that we can put into our reports as we go back to the board and say, well, here's what we found. This is how the data looks. This is what it means. It's not a proper engineering report unless it's got a lot of charts and graphs in it. So we're able to generate all that stuff out of the system. And it's not just eye candy. This is actual useful stuff.
So when you guys do the study, you guys are also similar to like when you get a CCTV, you guys produce a report, like an assessment. Do you provide your take on it? Like, hey, there's more problems here. Or is it more just like, hey, here's what the data is, and then you interpret it?
I think that's really going to be something that we would want to know what the engineers want and what the district wants. I mean, we can say, this is what we're seeing. This is what we think it means. And once it gets past the data revision, we don't really have expertise in that.
You collect it. You do some visualizations and say, hey, here you go.
Yeah. It really is going to be, what do you need from us? And I never produce a 3-ring binder that has stuff. We're doing all this electronically. When I was a grad student and working for a consulting firm, my job was to produce 3-inch 3-ring binders, and we don't do that.
No.
There is one other visualization tool that I think is really interesting, especially for board members, and especially in cases where the is coming from weather. And that's this, because we're going to lay the actual precipitation map and tie it in real time to what was happening in the pipes. And this allows the owners of the system to see exactly how precipitation is filling up their pipes. Also, it allows them to see how fast it's happening. And that's significant because if it's inflow, it's going to have a different speed than if it's infiltration.
Yeah. So this is kind of just tying it back to that network picture where you see they'll be like, this will flag this section with the rain.
Yes.
And you can see kind of visually here, oh, the pipe's full all the way down.
Yeah.
And then right here, you quickly say, this is how bad it is.
Right. And this is significant. Going back to identifying the I&I problem. We're just wrapping up a pilot in Oakland, California. Oakland went from, I think they have a 50 MGD plant, and during a storm, they get to 700 MGD. You can't even wrap your head around
how much water that is.
How much that is. And they've got all of their old abandoned digesters everywhere in the system. They haven't decommissioned anything because they just use it to hold rainwater when it comes rolling down the system so that they don't discharge into the bay.
Right.
So they're all of this infrastructure. This is a big problem. And if people are only beginning to realize that it's a big problem now because of the storms, well, that's fine, because now we have a tool for it. We haven't had an ability to do this before. So it's a tool that's matching up with a problem that we've always had, but we didn't really know, and now we do. And that's a very gratifying space to be in.
It is. Yeah, it's a really unique visual way to solve it. Like I said, the application super simple.
Yeah. Okay.
And thank you for coming on today.
My pleasure. Thanks for having me.
Yeah.